Hello, good afternoon everyone. Welcome to Liquid Brain. So today I want to talk about forestplot and how would you be able to generate this plot that you see on screen right now, as well as the other one here, which have a little bit more customization in terms of color, sample, legends, and grid line, and so forth. Okay, so I actually adapted the whole script from this blog or documentation of forestplot by Max Gordon. It is published this year in September, so it is a fairly new package, and I think it should be allowed to be maintained and used for the next many years to come, hopefully. Okay, so you can actually see forestplot used a lot in bioinformatics papers, especially in meta-analysis of multiple different things. For example, this data that I saw, which actually see the difference between the Cox analysis of BARD1 expression, as well as there's another package for meta microbiome R. There's a package for analyzing microbiome relative abundance, and you can also see there's an element of forestplot right over here as well as right over here. Okay, so you can also see more details about the function that I'm going to use, which is actually called forestplot, on this website attached here. So before we actually goes into forestplot, I feel like it is very important to really understand how to actually read the forestplot instead of just plotting it without understanding what we are trying to do. And for those that already understand what you want and why is it structured like that, you can go to the timestamp below and just skip straight to the script. So this is a very typical forestplot. Actually is adapted from a paper in 2006. As you can see that the first few columns are usually the study or subgroup. There'll be the name of the sample, and there'll be a little bit more details on, let's say, treatment and control, their background, and so on. There's also something like a risk ratio over here, or the odds ratio, or relative abundance, or Cox analysis variance on the other papers. So forestplot itself does not limit what kind of data you need to put on the plot, but rather it's just a way of representing data. So how do you understand this plot is that among all these studies, what is the outcome? So just to oversimplify things a bit for people that just come into this study. So for example, I have a null hypothesis of, I think everyone in the world only eats one apple a day. So I go and research 10 studies and see what is their finding and what is their outcome. So what I mean by one apple a day, that's kind of my null hypothesis. So if everyone finds there's one apple a day, I'm gonna put a dot in the middle with the error bar on the left and right representing the 95% confident interval, so that when the line actually crosses the null hypothesis here, I can claim that they're very similar to what I find fine, and they support what I do. Okay, so in this case, if it's an apple a day, it's going to be a middle. But if they eat more than one apple a day, it's a few research claim that a person eats 25 apples a day. I'm going to make a dot on the right. And if they say that on average, a person eats 0.02 apples a day, I'm going to make a dot on the left. So you can already see very clearly, if there's more dots on the right, means that people eat more apple a day on average, and there's a lot of dots on the left, people eat less apple a day on average. Okay, so that's the concept. So basically, there's a few technical terms that we might use later, just in case. What I say about the middle line of one apple a day is called a line of null effect, and just beware on the scale on the x-axis. It can be usually in the log scale, but in certain cases you cannot use a log scale if you want to. Okay, so everything on the right favors the control, or in this case more apple. Everything on the left favors less apple, or the other way around. Depends on the interpretation of the study. So we also have something called the summary, which is the last one. So everything on top, as you can see, is a dot or rectangular, but on the summary is usually a triangle, and we do not actually indicate the lines of the confidence interval in the summary. So combining everything, as you can see down here, you can see that on average in the summary, most people only eat slightly less than one apple a day, and there are a wide range of different reports by all the different studies, and even at this resolution I can kind of understand what is the overall big picture that you'll find from your meta-analysis. So that is the concept. So let's now go to the script. Again, for those that want to download the exact script that I'm using right now, you can go to my GitHub repo, which will also be linked in the video description down below. Okay, so the first chunk always, for me, myself, contains some extra information that you might need. For in this case, the website of the link just now, as well as the understanding of the forestplot website that I go through with you just now. And this one will be the package and in the website that I use to actually create this script. Most of them I actually copy paste directly from the website. You can also download the plot from the package or the person GitHub page if I'm not wrong. So first thing first, load in the library of forestplot and Dipler. So if you do need help installing packages, go to RStudio, click this button, install, and just type in the name of the package. So in this case, that will be forestplot. Type in here, press install, and that will install it into your R. And next time you run it, you can just click on this too, and that will load your package into the library. So in order for the whole thing to be more of a self-contained environment, we're not going to load any external data set using either a CSV or some other way. The whole thing is going to be created manually, in this case using this data set, into something called Cochrane from R metastructure. So Cochrane from R metastructure, you can see. So this is the data set we created in that chunk of code in order to plot our forest plot dot and line later, where means represent the dot, lower and upper means the confidence interval represented by the line. Okay, so once we're done, we have to also create the text label. So you can see that in the Cochrane from R metadata, the first two lines and the line number 10 are all empty. So why is it empty? Is because when we create the table structure over here, you can see that line 1 and 2 is just the title or the description of that column. So when we want to plot it, this needs to be shown on a table, which is why you have to put some spacing in your data so that you will understand that which line does the sample start from. In this case, that will be line number 3 on Auckland. Again, you can add more data here if you want to, and just to add more line into the forest plots that you have. Okay, so that will be the data that we see just now. So once we're done, we actually are ready for the forest plot already. So yeah, this is the outcome by just simply fit in Cochrane from our metadata into a forest plot with this argument. So let's go through one by one on what are they. So the first one is labeled text. Labeled text is the text, the table text, which is what we created just now. This one, column 1 to 4. So you can see column 1 to 4 is the labeled text. So you can see that all the data that was shown in the data table that was table text just now is represented by the first 4 column over here. So the next one is summary. So is summary actually highlight whether a certain rows is a summary line or not. In this case, should I bold the text within the column or not? So in this case, where the first 2 line is a summary, the next 8 line is not a summary, and the last one is a summary. So what's that represent is that the first 2 row over here is a summary, and the next 8 one is not, and the last one is our summary row. So we will be bolding the text of line 1, 2, and 11. So can you see in the plot 1, 2, and 11 are all bold? So that's what it's trying to do. So the next one is clip. Clip means that the upper and lower boundary that you want to put into your plot. That's your confidence interval. So in this case, if it's lower than 0.1, you can see that it's not being plotted over there, and everything above 9.5, it will not be plotted. But again, our data only reach until 2, so we don't have any 9 to 5. But we do have some lower than 0.1. You can see that 1, 2, 3, 4 are represented by the arrow. So what this is trying to do is not to overscale the scope of the overall horizontal length of the forest plot, so that you can actually see a better spread of something that's more. So your forest plot won't be ruined just because a single study has like overly big confidence interval and so on. Okay, so x log equals to true means we want log on the x-axis, and the last one is the color, which is the royal blue, dark blue, and the royal blue again. So that's why you can see everything here is a blue. So that represents the colors for the box line and the summary rectangular over here, or diamond over there. Okay, so the same one is doing the same thing exactly again, but now instead of creating two different tables, we are combining all the table into one, so that it's, I would say, easier to manage when you have so many things you need to look at later. So you can actually see that Cochrane output over here, which is actually an exact example of what we did just now, just that instead of actually doing it as a two different table, we combine them into the same table with another one of a summary column, so that it's easier to plot like this here. Okay, so you can just fit in the label text equals to study, def steroid, def placebo, and OR, so that will be the name of the column, and that we just fit it in. And we have a summary equals to summary, which is again the name of the column. In this case, it's called summary. And we have the clipping, we have the log, and we have the color. So that will be exactly the same data that we look at just now, just that in a single table instead of two, and you don't have to feed the summary row individually into the summary column individually as a separate element again. So it will just be coded into the table before you plot them. So in this case, if you do want to do some customization of the previous plot, you can also see here. So what I changed over here is here, the third element over here, fourth element over here, we have the list, which is 3 and 11. So the line type is equals to 1. This is the line width for the column 1 and 4. And the color is this color. So what that means represent in that in line 3, I want the line type to be 1, which is a solid line, and line type 2 is a dotted line. And you can change many different kind of line type. I don't remember which is which, but I can try to illustrate one by one to see which one is your favorite. And you can also change the color based on the hex code over here. And again, you can also change the color. Here I've actually changed the box and line to red color, so it looks more striking. And you can also change the color of the summary diamond, as well as the color of the horizontal line and individually around here. So that would change the color of all this thing and nothing much else actually, the line type and the color of the figures and so on. So that kind of conclude our first table on how to create a basic structure of a forest plot and how to customize each of them. So now let's go a little bit deeper into the individual customization of the elements. But in order to do that, we're gonna actually move away from the previous table that we have, because you can see there's a lot of different elements. So we're gonna simplify the table using a different data set. So in this case, we're using a data set called DFHQQOL. No idea what is it named like that, but it's basically just a research with, again, a label text, an estimator, the estimates, a mean, lower, upper, and the group. Okay, so very similar to the structure that we see just now. So if I actually run this, you can see that the concept is the same, but now the colors are being actually represented up here on a slightly different structure. Okay, so yeah, we again fit in the whole thing where we only do a certain a group first. So from the thing just now, you can see there's Denmark and Sweden. So in the first plot, we only want Sweden, which is why we run a filter based on the group, and we do a bunch of summary that we only pull out Sweden to actually plot this line. Okay, so once we're done, you can actually see that the colors are the colors, the label text are the table text, and we're gonna do some Sweden, and we're gonna bind a row just to make sure that the summary get represented correctly, the format of the plot get represented correctly. So yeah, you can try to remove them and you can see the effect on the outcome on that. Actually, let's do that. So look at this, I'm gonna do it right now, and you can see that why do we need that row to begin with. Yeah, it doesn't work. So 4 rows in your mean argument, and the label has 5 rows. So yeah, the row of the table text and the thing has to be the same. So I believe that is actually one of the summary row from above. So let's move on. So what we do is sometimes there's certain requirements of the font type and in certain publication, for example, or you just want to maintain the consistency of your text and your figure. So in this case, the font is pretty easy. Just specify a font that you want to do. the different way of representing font and depends on the availability of the R backend. But here they're using mono, and if this thing doesn't work on you, there's separate line that you need to include into the script for it to work on Mac OS if I'm not wrong, because the name is represented slightly differently on this. They're not really part of the R system. They're a bigger system in backend. Okay, so just change the text group into this, and you should be able to change the font type of your forest plot. So the next one is to change the confidence interval. So confidence interval, like I said just now about the clipping, which is actually what we want to specify on the x-axis over here. So you can see that from up there, you can see we are using we use a specific, I believe we're doing it here on the clipping. Oh no, we're not specifying any clipping. So as you can see from the initial one, it's minus 0.125 to 0.05. But if you actually use a different clipping mechanism, you can see that they're slightly different, because the last study over here has a much bigger confidence interval, and that stretches that confidence interval, making the three other confidence interval actually strings. So it looks like all the studies are very far away, and it's not necessary so. So what we want to do is actually clip on this side, so that it looks nicer and more condensed and more compact in the middle. So again, this is only for sample. When you have 100 of them, one of them might be so far away, it ruins the whole graph. So that will be the use of clipping for what you will need to do. So again, this is one last one to change the confidence interval. And yeah, so you can see that once we change it here, you can see that it looks slightly better than up there, because this actually get represented by the arrow, meaning that there's more data there. Don't forget about that, okay? So the last one is to change the box size. So again, this will depend on how big is your graph. If your graph is very big, you do not want the box to be too big to crowd the overall situation. And if your graph is very small, in this case only 4 elements, you want your box maybe to be bigger, so it looks nicer. You can just change the box size over here to make it bigger and smaller, and so on. So just now it was not using, so 0.2 actually make it slightly bigger. The default should be 0.1, for example. So the next one is multiple confidence bands, which is you have 2 different samples over here. Okay, so you don't have to care about most of it. It's just more of a customization process. But what you really need to understand about grouping is we're using dplyr in this case for a group by situation. So what it does with the group by is that the first thing it will group based on Denmark, draw the thing, and then you add on to Sweden to do all that thing. Okay, so in this case, the FNCI norm is just how the box is drawn from the normal CI, the normal confidence interval, the size of the box, the margin of the line, the clipping, the x-axis that I said about just now, and all these two are the graphical parameters of how the shape should look, the color, the shape, and so on and so forth. So the box, the first one will be blue color, the second will be dark red color. Both of them should be on this color as the line, and then on default they have like a vertices. Again, you can change this around, and actually I added one very convenient way of visualizing what you're feeding in here, which you actually can copy and code down there to see that, oops, got one there. So yeah, this is what you actually feed in. So the fill is blue, and this color, the fill is blue, the color means that the line outside, the shapes, and the second one will be dark red inside, the same color outside. I believe it's a gray color over here. So that's what you can see from the thing, yeah. So the next one will be again choosing the line type. Like I said just now, line type are being shortened to LTY.CI, which is the confidence line type of the confidence interval. In this case, 2, 1 means 2 is the dotted line, 1 is the solid line, 2 is the dotted line. So you can see that on sample 1 is a dotted line, sample 2, the red color here, is a solid line, and so on. So you can again change 3, 4, 5, 6. I believe they're all dotted line in some way, just that they're dotted in a different way. The frequency of the dot are slightly different from one to another. So the last one is legend. So legend just add it in. I think that's pretty straightforward. I would suggest you to run a group and actually convert the group into a list. But I believe this is actually more simple, just in case that you want your legend to be shown slightly different from how you structure a data set. So you can see that the first one is Sweden, the second one is Denmark, which is why the script here has shortened them to Swedes and then and so on. So it will look somewhat like that after all the customization. And the last one, not the last one, sorry, a little bit more customization would be, for example, the ticks on the axis. So in this case, act ticks is 1, 2, 3, 4. So you can see 1, 2, 3, 4, and only those 4 will have the ticks. And in this case, maybe you want 2 to look equally to next to each other, you can also do that. Okay, so the last one is use object to define ticks and grids, which is the same thing, just that instead of doing it inside the forest plot, you just define X tick outside the forest plot and fix and just load it in, which is exactly the same thing, just done differently in a different way. And if you have a lot of ticks, and if your ticks, for example, have a very long code, this might be easier to do. So the next one is the grid. Again, same thing, just go to grid here, just say true, and the grid will actually follow the ticks that you define. So 1, 2, 3, 4, you can see 1, 2, 3, 4, 4 line. And the line of the null hypothesis will almost always be there, because I believe everything up there has a line of null hypothesis, and the grid just add-ons to the other grid. And yeah, you kind of need to have the 0 over there. Sorry, you need to have the line in the 0 null hypothesis as a default for most of it, and I don't see why you would need to remove them. So the more grid manipulation, it's not the last one. I don't know what happened to me today. So yeah, for the grid, it's just change a different structure. The line type is number 3, and you can change both the property of the line and the color of the line. Yeah, that's actually the last one. So yeah, so basically what we've done today is we looked through a basic concept of forest plot, how to manipulate the title, the data structure for you to fit it in. Basically this one, how do you construct them, and maybe how do you manipulate them from your raw data set into this data set first before you fit it into the forest plot. So after you have fit it into a forest plot, how would you be able to properly display the data and manipulate all the individual arguments for the plot to actually fit the requirements of your study and how you actually tell the story. So that would be everything that I need to say today. So I hope you learned something from the forest plots, and we'll see you in the next video. Bye.